Now, question number 1, we are given the function f of x is equals to 3 divided by x minus 2, then minus 1. And this is a hyperbola. And g of x is equals to 3x minus 7, and that's a straight line. Now, the first question, on the same set of axes, draw the graphs of y is equals to f of x and y is equals to g of x. All intercepts with the axis, asymptotes, and points of intersection should be clearly shown, and that's for 7 marks. So let's first take a look at this hyperbola function. With the hyperbola, we need to know our asymptotes. So in this case, our q value is a -1. So that means our horizontal asymptote, we have the value y is equals to a -1. And then for our vertical asymptote, we have x minus 2 is equals to 0, which tells us we've got x to a +2. And then, okay, let me just do a Cartesian coordinate and then indicate these two asymptotes. And then I will shift my focus to the intercepts of both functions. So roughly we can say, why is it a black pen? Let's use a black pen, or rather, let me just do a blue pen. And then my x-axis, let's do it like that. And then the y value is equals to a -1, which is our horizontal asymptote. Let me put it there. And then for this red pen, and then the vertical asymptote, x is equals to a 2, so we'll have that there. And then this is a +2, and y equals to a -1. And now for my x-intercepts of this function, I'll put my y value as 0, so that means I'll have a 0 equals to this function. So I'll just transpose -1 to the other side. I'm just trying to save space here. No, it's going to be a +1, so I'll have 3 divided by x minus 2. And now I'll cross multiply to get rid of my fraction. And that means for our, that's going to be +1, right? No, that's going to be +2, so that's a 5, meaning we have 5 and 0 for our x-intercept. And then for the y-intercept of these, I'll put x is equals to 0, so I will have y is equals to +3 divided by my x is 0, so that means it's -3 divided by 2, then -1. And this is just -3 minus 2, all of that divided by 2, which is -5 divided by 2. So my y-intercept, it's a 0 and a -5 divided by 2, which is approximately, let me see, where's my calculator? -5 divided by 2. That's -2.5. That's -2.5. If ever that is 1, so that means -2.5. Let's say 2 is there, then -2.5 is somewhere there. -5 divided by 2, and then +5, that is 1. No, that is 2, 3, 4, 5. So let's say 5 is there. Yeah, so obviously since our a is positive here, we should have known right away that this function would lie on the first quadrant and the third quadrant, because our a is positive. But either way, our intercepts should just give us an indicator where this function is. And then we'll have another part of this on this side that goes to infinity. Similarly, never touches our asymptotes. And that's it for our hyperbola. Now let me erase this. Oh, it's happening. Okay. And then now for the straight line function, this should be straightforward. So we'll put our x is equals to 0 to find our y-intercepts. So that means we have y is equals to a negative 7. So if ever x is 0, we've got a negative 7. And for the x-intercept, we put y is equals to 0. We'll have 3x minus 7. And then we'll have negative 3x, and the negatives will cancel. So we'll have our x value 7 divided by 3. So if ever we have 7 divided by 3, our y value is 0. And 7 divided by 3, that's approximately 2.33. 2.3 recurring. So that is 2. So 2.3 is somewhere there. Let us put it there. And then this other, it's a negative 7. So that was negative 2.5. Then 2.5 there. Let me just say my negative 7 is somewhere there. No, my negative 1. Yeah, negative 7 somewhere there. And then the function of g of x, it's a straight line function. Let's go cross that. Okay. Yeah, but if ever you draw this according to scale, you should get a better version of this. So those are our two functions. However, we still need to show our points of intersection. So to find the points of intersection, I'll equate the two functions, then solve for x. So f of x is equals to g of x. That is to find these 2 points, what these coordinates are. Let me name that the first one it's a, and then this one I will say it's b. Now g of x, it's the hyperbola, right? It was 3 divided by x minus 2, then minus 1, is equals to a straight line 3x minus 7. I will transpose negative to the other side so that I have 3x, that's going to be minus 6, 3, x divided by minus 2. Okay, now to get rid of this fraction, I'll multiply everything by x is minus 2. So we have 3 this side, and then 3x minus 6 into x minus 2. So we'll have 3x squared, then 3x, that's a minus 6x, and then another minus 6x, then I'll have minus 12x. And then negative 6 times a negative 2, that's a positive 12. And then transposing the positive 3 to the other side, it's going to be a minus 3. And so I can simplify this and say 3x squared minus 12x plus a 9. I can divide everything by 3 just to make it easier to factorize. So it's a minus 4x, then this will be a positive 3, right? So to factorize this, both of our factors, it's going to be minus and minus. Factors of 3, that's just 1 and 3. So that means our functions intersect at x is equals to a positive 1 or at x is equals to that positive 3. So obviously our x is equals to 1 should be here. That's at D. So we have 1 there. And then at that point we have the x value 3. And then to find the y value, I'll use my straight line function. So the straight line function is 3x, so 3 into 1 minus 7. I'll have a negative 4, which should be this part because our y value is here negative. And then for that other one, we have 3 into 3 minus 7. That's okay, 9 minus 7, that's 2. So our y value, that's 2. So that should be enough to obtain the entire 7 marks. Okay. Now question number 2, use your graphs to determine the values of x for which f of x is equals to g of x. So those are our 2 points of intersections which we just recently found, and I indicated them as the point A, which was I think 1 and a minus 4, and then the point B, yeah, which was the x value, what was it? Okay, the y value was 2, the x value, it was 3. Yeah. So you can just say, oh, rather they just want the x value, so our x is 1 and 3. My mistake, not the coordinates, just the x values. So we have the x values equals to 1, should I say, and x is equals to 3, and then 3.22, where f of x is greater than g of x. So we need to use our function where f of x is greater than g of x. So our f of x is the hyperbola, right? So we need to view where our hyperbola is above the function g of x. So I will indicate that I'll just highlight my function of f where it's greater than. Okay, let me use a different pen. Let me use pink. So my g of x is greater than, or rather my f of x is greater than g of x from this point up until negative infinity, and then coming from the right of the asymptote up until this point. So how do I present that mathematically? So I can use the interval notation and say, let me write this here, just my function of f of x where it's greater than g of x. So it's from negative infinity up until at that x value, which is just a positive 1, and it's not included, union of from my asymptote, which is also not included, and the asymptote it's 2, right? Up until, yeah, we'll always know up until that point, which is the x value of the intersection, and it's also not included. So this is the solution. I'll move that there, then I'll compress it. That's for question number 3.22. And then question number, the third question rather, we are asked to indicate the values of x for which the first derivative of x is less than 0. So f of x, let us see, we've got a hyperbola. I wonder, in grade 10, do we derive hyperbolas? Okay, let's just see. By the way, this is a grade 12 question, so I think at this point the grade 10s can just fast forward to the next section. So, and by the way, let's just do it. Let's see, f of x, it's equals to 3 divided by x minus 2 minus 1, right? And so I will rewrite this function as, so that it's much easier to derive. I don't want to use the quotient rule, minus 1. So this is still f of x. So I will use the chain rule to find the derivative of this function. And what the chain rule says, let's say we've got an outer function f of x, and this function is a function. Okay, how do I put this? Instead of saying f of x, we'll have f of x as a function of a function. So a function of a function, I'll say there's another internal function g of x. And how do I derive this function? Because this one, it's easier to derive. We'll just find the derivative and say that's the derivative of this function. But in the case of the chain rule, the derivative of that function, we first take the derivative of the external function, which is the bigger f. That's going to be f of prime of g of x, right? And then we multiply this by the derivative of the internal function. So this is the chain rule. Yeah, and if you do have an interest to this, I think this is first year calculus. Yeah, it's sort of like dy divided by du, then multiplied by du with respect to dx. This is the chain rule. So this is the concept we use to derive this function. So in this case, the bigger f is this entire function, and then the internal g of x is this function inside our braces. So deriving the external function, I'll say this is going to be negative 3, and then x minus, we keep that the same, and then that's going to be minus 2. The derivative of a constant is just a 0, and then the product, not the product, multiply this by the derivative of this internal function, which is just the value 1. So that means f of prime of x is equals to a negative 3 divided by x minus 2 whole square. So that's how we derive this hyperbola. And then we need to find where the first derivative is less than 0. So what I did, I just went ahead and used an online graphing calculator to find the sketch of these, but you can attempt to do this on your own if you can. However, x is not equals to 2 because we will have an undefined. So by using my graphing calculator, this is what I found. So notice that our function is always below the x-axis, so meaning this is less than, f of prime of x is less than 0 for all of our x values except at that asymptote where the line, it's the x value is equals to 2. So you can say negative for another solution. This is correct and that is correct. Okay. Yeah, but I think this question, I think this is an IB question. So, but for grades 10, this is not necessary. Grades 10 and 11, I think this is good practice just for grades 12. And then question number, okay, 3.3, determine the equations of the axis of symmetry of f. Axis of symmetry of f, okay, f is a hyperbola, so I will go ahead and erase this again, just to create enough room. For the axis of symmetry, we'll just take our, let us take rather our asymptotes. We have the asymptote y is equals to minus 1, and we have x is equals to 2. We'll use these 2 points to find our equations of axis of symmetry, because our original axis of symmetry, we have y is equals to x and y is equals to a minus x. And these axes of symmetry are for the function y is equals to 8 divided by x, okay, plus 0. And since our function is shifted 2 units to the right, so for our axis of symmetry, we'll just say, okay, we'll say y plus 1, right? And then for our x, we'll say x minus 2, and then let's simplify this. We have x minus 2 minus 1, and then we'll have x is minus 3. And this is our first axis of symmetry equation. And then for the other one, which has a negative gradient, we'll say y plus 1, same thing. However, this time we want a negative gradient, so x minus 2. So we'll have negative x plus a 2, then minus 1. We'll have y is equals to a negative x plus 1. And if ever I were to sketch those two lines, okay, I'll have the other one that has a negative gradient, which is minus x plus 1. And then that other one with the positive, that's x minus 3, should increase going that way. And then question, the fourth question, 3.4. Determine the equation of a graph created after each of the following transformations of f. Okay, our f is our hyperbola. We need to perform some transformation. So the first one, a reflection of f about the x-axis. So whenever we are reflecting like a hyperbola along the x-axis, let's just negate our x. Instead of just saying f of x, when reflecting a function of f of x, we'll just negate the x and say, then we have 3 divided by, instead of x, it's just negative x minus 2 minus 1. So this will be a negative 3 divided by x minus 2. And the sketch of this function should look like something. Instead of having our function here and there, we'll have our function on this on the second and fourth quadrant. Yeah, I'm not sure about the intercept, but this is how it will look like, because we just reflected only on the x-axis. So you just negate your x and then you simplify your expression. Okay. I have to remove that. Oh, what's happened? Okay, delete that. That. And for 3.42, a translation of f by 3 units to the left and 2 units upward. So we're shifting our function 3 units to the left. We're going that way. We're going to the negative side. So in other words, we're supposed to have something like x is equals to negative 30, right? 3 units to the left and then 2 units upward. So with the y values, we just have y is equals to 2, because we are moving to the positive direction, up. But how do we perform this transformation to f of x? So f of x is given by 3 divided by, okay, x minus 2, then it's minus 1. So to perform this translation, I will just say, instead of x, I will just say x plus 3, right? And then I want to move 2 units upwards in the y direction. So in this case, I'll just say 3 divided by x minus 2, then minus 1, 2 units upward, positive 2. So, okay, made a mistake. I said f of x plus 3, so I was not supposed to write just x minus 2. So instead of the value x, it's supposed to be x plus 3 and minus 2. Okay, let me just tidy that up. So it's a 3 divided by x plus 3 minus 2, then minus 1, and then I move 2 units upwards. Now to simplify that, I will have x plus 1, then plus 1. And if ever you were to graph this function, this is the function after these two transformations. if ever you graph this function, clearly you should see that your function has moved at least 1 unit up and then 2 units to the left. Okay, and we can see that by using our asymptotes. So meaning our y asymptote is going to be a positive 1, and then our vertical asymptote is going to be a negative 1. So if ever we shift this 3 units, that means we will say positive 1, 0, and then negative 1. Yeah, which is good. And then we shift this 2 units upwards, we'll just have -1, then 0, then 1. Yeah, so this should be correct. And that's how the function is supposed to look like after those 2 transformations.